Okay, this is going to be page 180, 181. Looking at the example they give you, there's no single transformation that would make this happen. You have to do more than one. So they're talking about you can reflect it and then translate it. So you would see that the reflection would kind of look like this. And then that's still not enough. To get it here, you'd still have to translate it. It's saying you have to put up 3 units. So 1, 2, 3. Okay? Describe a transformation that would make PQRS move over here. So I don't want to reflect because it would be pointing the wrong way. So let's see what I can do. I definitely want to translate. If I have to do a rotation, it would have to be a 360-degree transformation. So I'm really just looking at what I want it to look like. So I can translate. So a series of transformations, I'm going to translate this going to the left. 1, 2, 3, 4, 5, 6, 7. Translate PQRS left 7 units and up. Let's see how many we have to go up. 1, this is S, which matches here, so 2, and up 2 units. Okay, this translation slide, we already know 7 and 2. Okay, we know exactly how that would work. Okay, so if you were to do that, that would transform it, that would slide it, that would move it. Okay, that's 180. 181. Transform this by reflecting over the y-axis and labeling it. So let's do the first thing before it starts to get crazy. DEF, if we have to transform it over the y, it's going to go here. 1, 2, 3, 4. 1, 2, 3, 4. That means, and this is up 2. So here we go. And it said to label it PQRS. Okay, DEF. P, so P goes here, QR, got it. Transform PQR by reflecting over the X, okay? 1, 1, 2. Now what do I have to call this one? UVW, okay? UVW. So I want to put U here, W here, and V here. Just gotta switch these two. What is a single transformation that transforms this to this? So what can we do that would make that work? Well, you can notice that it's not in the same direction. So it's obviously a rotation. I could rotate the triangle DEF. Let's see, if it's going here, it's 90, but here it's 180. 180 degrees around the origin. All right, which transformation transforms this over to this? That's definitely looks like a rotation to me. It's going down, it's rotating. It's not 180 because remember 180 is going down here. So I'm going to cross this one out. It's not a translation. And it's not a reflection. It left us only with C. Okay. If she thinks going 1, 2, 3 to the right works, she must have confused the points. Aaliyah confused point O as point P, but they are 2 different points. Point O stays point O, and point M becomes point P. So that was her error. She thought, oh, I can just slide it over, not realizing that this is M, and M is what slides over to become P. All right, that's 180, 181. We're doing so well. We're going to go on to 182. To show that A and B are congruent, which transformation would you use? Okay. If I want to show they're congruent, I could do a reflection and then move one unit up. Is that an option? Rotate 180. If I rotated 180 to show A and B as being congruent, that would work. So this would work, but also I'm noticing if I translate 4 over, 1, 2, 3, 4, and 1 up, that also works. Reflect over the X, and then reflect over the Y, that also would work. So we've got a situation of all of the above. Trisha plotted these points for 2. Then perform these translations so that we can map to its original location of 4, 2 again. Sort the transformation so it maps back onto itself. All right. Well, let's do rotate 180 degrees around the origin. Okay. So if she rotates, then she can reflect over the y-axis. Okay, so it was at 4, 2. Then it rotated 180 degrees. So if it's at 1, 2, 3, 4, 2, that rotates 180 degrees. It's going to be over here at -4, -2. But then it reflected over the y. So now it's back over here. So now we have to go 2 right and 3 up. 2 right, 3 up. Then 2 right, 3 up. Okay. Translate 2 units right and 3 up. Translate 2 units left and 1 down. Okay, the second option, so this is option 1. Option 2 would be translate 1, 2. Translate 2 left, 1 down. Option 2, rotate 180. Option 2, reflect over y. Option 2, translate 2 units right and 3 up. Now the option 2 is what's in the answer key. Okay, both work, but if you want to have the exact same one, probably as Mr. Riley, you probably want to put the second option. Okay, that's 182. Got 183, and then we're done. These are all showing the coordinates and its image after it was translated. So it went from 2 to -2. So the difference in x and y, okay. The x is moving left. So going from 2 to -2, it's going to 1 to 0 to -1 to -2. So that's 4. Moving left 4, which makes sense because it's going from 4 to 0. And the y is moving, all right, the y is staying at 1, staying at 2, staying at 5. Moving 0 spaces. Okay. What transformation produced it? So if this is exactly the movement that it made, it basically means it's moving the translation was 4 units left, right? Because there's 0 spaces going up or down. So just 4 units left would be perfect. All right, describe at least 2 ways to transform A to B. All right, I like rotating because I can definitely see that it's rotated 180 degrees. Row number 1, number 2, rotate 180 degrees around the origin. You always have to stay around the origin because they can also tell you to rotate around here or rotate around here or rotate around here, but this is strictly straight through the origin. So you can also do a reflection. So reflect across the y and then reflect across the x. Reflect A across the, well, yeah, y axis, then reflect across the x axis. All right, Jenny says that if you translate, rotate, or reflect, the area of the image is the same. Do you agree or disagree? Of course, yes. The sides, length, and width are all congruent. If the shape stays the same, the area will stay the same and be equal. All right, so that's 181, 182, 183.